Today we're going to go rapid fire through some examples, which will be applications of the mods that we discussed in the previous video. So let's get started. So how would we find 5 to the 100th power mod 4? So what's the remainder there? Well, first you would say five is congruent to 1 mod 4 because 5 divided by 4 leaves a remainder of 1. So really all this is the same as 1 to the 100th power, and 1 to any power is 1. So the answer to the first one is 1. Alright, let's go to the next one. So let's change this to 6 to the 101 mod 7. So in this example we'll see why negative numbers are useful. Although 6 is already in the 0 through 6 range when we're dividing by 7, because these are the possible remainders, let's turn a 6 into a negative 1. So rather than treat it as a 6, we're going to go in those islands and subtract a 7. So this is really the same as negative 1 to the 101st power. So overall, why are we doing this? The strategy is, since we're raising numbers to really high powers, we want to make these either ones or negative ones, because we can raise ones and negative ones to really large powers. Now that might be easier and harder for some problems, so let's see what happens here. Negative 1 to an odd power is just negative 1, and so we're done. If this were 102, that would be an even power, that would be positive 1. So let's go to the next one. 7 to the 143rd mod 4. Now this is actually the problem from one of the previous videos. And so we have two options of doing this. I'll show you guys two ways. So the first way is 7 is the same as 3 mod 4, but 3 we don't want to raise to such a large power. So what we can do is try going up a few times. In general, the idea is go up a little bit, shrink, up, shrink. So grow it, shrink it. So let's try 7 squared. 7 squared would be 49, or you could do 3 times 7, doesn't matter. So 49 mod 4 happens to be 1. Or you could have done 3 times 7, which is 21. 21 mod 4 is 1. So this is good. That means every 2 7s get us a 1. So now the question becomes, how many sort of 2s can we fit into 143? So you could think of this as 7 squared to the 71st power, because a power to a power you multiply, that's 142, and then we have this one leftover 7. So altogether that's 143 sevens. Why do we split it up this way? Because this part is 1. So 1 to the 71st power is just 1. So this would become 1 times 7, and that's going to be 3, because 7 mod 4 is 3. So the answer to this one is 3. Alright, moving on to this one. Oh, sorry, in the previous one, I said there's a second method. So the first method was saying 7 to the first is 3, not very good for us. 7 squared happens to be 1 mod 4. But we also could have said 7, rather than calling it congruent to 3 mod 4, we can subtract off another 4 and say, hey, this is really a negative 1. So and that way we can directly do negative 1 to the 143rd power is still negative 1, but then we want to transfer this to our normal 0 through 3 range, so we add a 4, and we get the same 3. So that's the second method. Alright, so how would you do this one? Well, 4 mod 6 is just 4. You could maybe convert this to a negative 2 by subtracting 6, but negative 2 to a large power is still problematic. So let's just hunt for a pattern. So 4 to the first is just 4. 4 squared is 16. 16 mod 6 leaves a remainder of 4, right? So that's what that's going to be. Let's try it again, just so we can get the hang of things. 4 cubed is going to be 4, this 4, times another 4, 16. In other words, it's always 4. So no matter what the power, so we're done. The answer is 4. All right, let's go to the next one. 3. Now 3 to the 103rd, again, let's hunt for a pattern. So 3 to the 1st is 3, 3 squared. Now we're just dealing with the remainder, so that's going to be 9. 9 mod 6 is again 3. So this is just going to stay 3 all the time. So we're done. That's just 3. All right, let's go to the next one, which is going to be a little bit trickier. All right. So here we could say 7 is the same as -4. But again, -4 to a large power, we can't really do that. So let's just look for a pattern again. 7 to the 1st is just 7. 7 squared is 49. 49 mod 11, or 49 divided by 11, leaves a remainder of 5, because 44 plus 5. So now, for 7 cubed, rather than actually cube 7, let's multiply 5 by another 7, so that's 35. 35 divided by 11 leaves a remainder of 2. So 7 cubed mod 11 is 2. So we're just hunting for a pattern. So we're going to do this again. 2 times 7, it's going to be 14. 14 mod 11 is 3. Now the reason I'm hunting for a pattern is that there's only so many remainders, and eventually with 7 and 11, these are going to start to repeat. So if we go long enough here, we're going to see one of these start to pop up again. So 7, so in other words, have hope, don't give up too early. 7 to the 5th would be this times another 7, which is 21. And that's actually great for us. 21 mod 11, you could say it's 10, because the remainder is 11 plus 10, the remainder is 10. Or 10 subtracting 11 is -1. Bingo. So we got either a 1 or a -1, in this case a -1. So now we can say every 5 sevens get us a -1. So -1 to the 5th. How many 5s are in this number? It'll be to the 201st. That gets us 1005, a power to a power. But we have 1005, another 4 left over. So that's this part. Now we already know -1 to an odd power is still -1. 7 to the 4th is congruent to 3. So this is -1 times 3, which is going to be -3. Now for the final answer, we have to bring it into 0 through 10 range. So we just add an 11 to this. -3 plus 11 is +8. So that's our answer. +8. All right, for the last two. So I'm not going to copy them over. Let's just see what happens. So mod 5, 27 mod 5 is just a 2. So this is really saying 2 to the 71st minus 81st. So this is really just 1. 81 mod 5 is 1. So this is -1 to the 31st. A 3, we'll leave that. And a 4 happens to be a -1. All right, so these parts are easy already because we already got 1s or -1s. This is just some -1, -1 to an odd power, -1 to an odd power again. Every 2 2s, so 2 squared is a 4. And a 4 is a -1. So this is really 2 squared to the 35th. That gets us 70. And to get that 71st 2, we multiply by another 2. So this term becomes, this 2 squared is -1. -1 to an odd power is -1. So we're going to have -1 times 2. And that's the result of this first part. All right, let's copy this over. The -1 is from here. Now the 3, again, we could square it. 3 squared is 9, which happens to be congruent to what mod 5? It's congruent to -1, which is, again, great for us. So -1, how many 3s do we use up? We used up 2 of them. So that means we can rewrite this entire term as 3 squared. So what's 119 divided by 2? That's going to be 59 with 1 left over. So we have this extra 3 over here. And this part is really just -1 to an odd power, which is still -1. All right, so we got all the hard parts. So the first part turns out to be -2 minus 1 plus -3. So let's, okay, and then that's another -1. So here's the final result. So we're going to have -2 minus 1, which is -3, minus another 3, -6, minus 1, -7. We have to bring this into 0 through 4 range because this is mod 5. So we're going to add a few 5s. So plus 5, -2, plus 5, +3. So our answer is 3 to the second to last one. All right, finally, the last one. Now these are quick fire just to make sure you can see how we apply this stuff. All right, we're trying to find this mod 4. So we're going to simplify everything first. So 56 mod 4 is going to be what? So we see, okay, that's actually divisible by 4, so this is 0. So 0 times anything is 0, so that's garbage. 21 mod 4 is just 1, so this is -1 to the 37th, which is just going to be -1. 987, to check its divisibility by 4, we just look at the last 2 digits. And 88 is divisible by 4, so 87 happens to be congruent to -1. Again, so -1 to some weird power. Odd power is going to be just -1. Plus 3 stays plus 3. So our final result is the result of this. So -2 plus 3 is +1. And since that's already in 0 through 3 range for our reduced remainder for mod 4, that's our answer is +1. All right, I'll see you guys in the next few videos where we go through some more examples.